Hey, now we're going to talk about half-life. Half-life is the amount of time medication takes in your system to become half its original strength. So when you have medicine, when you take medicine, then all medicine has a half-life. And just because it's time to take another dose of medicine doesn't mean that all of it has depleted in your system. In other words, if you take Advil, you take two now, and then in 4 hours you take two more. In 4 hours, that 500 milligrams, 600 milligrams, however much Advil you put into your system, it's decayed by half its original strength. So when you take more Advil, it becomes more effective in your system and stronger in your system. And then that too has a half-life. And the amount of time that it takes to decay, to have like traceless amounts in your system is a while. It could be over a while. So it's going to go down by half, by half, by half, by half, and smaller amounts. So that's why when you take a drug test, for example, those traces are in your system because the half-life of that drug is still being calculated into that drug test. Now, if you hadn't done drugs for a while and the test comes back clear, it's because in your system, it's given enough time where it's now untraceable. So, interesting fact, huh? That's also why when you're on antipsychotic drugs for a while, when you come off of them, you can't just go cold turkey and not take any more because your body needs a certain amount to sustain what it was doing for you. So you can come off of drugs, but it has to come down slow amounts of time because of this half-life factor. So we're going to actually see what half-life factor is and how much is actually in your system the more you give your body. So let's start with this one. The doctor gives our patient 600 milligrams of Advil as needed every 4 hours to take for pain. Advil has a half-life of 4 hours. Assuming her patient only needs to take Advil one time, how much Advil will still be in her system after 16 hours? We're going to give 5 cycles of the drug representing half-life, and we're going to show our results on this graph. So the time that the doctor gives Advil, right now, if I were to take Advil, I would have 0 milligrams in my system. So I have 0 right now. If I take Advil, I'm going to put hours up here so I don't have to label everything. The amount of milligrams in my system, if I take it right now, is 600 milligrams. So then it says take it every 4 hours for pain. Advil has a half-life of 4 hours. So every 4 hours I'm going to rate how much Advil is still in my system up to 16 hours. So if I don't take it again, in 4 hours I'll still have 300 milligrams in my system because I divided that by 2. In 8 hours I will not have 0. It doesn't go 600, 300, 0. It decays by half its strength. So I'm going to divide that by 2 to get 150 milligrams. And then I'm going to keep going. In 12 hours, it's not 0. I'm going to divide that by 2 and have 75 milligrams. And then in 16 hours, when I divide this by 2, I'm going to have 37.5 milligrams left in my system. So if I were to be tested for how much Advil is in my system after 16 hours, it would say 37.5. Now, if I want to graph this, we're no longer doing linear equations because the slope isn't the same. It's going the time is the same increments every 4 hours. However, the amount that it decays is half the strength it was before, which is a different amount every time. So on our graph, I'm going to come up with some stuff, and I'm going to go, let's do 2, 4, 6, 8, 10. Let's go down by 2. So let's go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And then we'll go up on the side by, I'm going to skip every other one and go up by 100. So 100, 200, 300, 400, 500, and it's going to go off the chart by 600, but we're going to live with that. So the starting point is always on the y-axis, which is pretty nice. So the starting point is right here at 600, where this is my x values and this is my y values. So at 0, I have 600. At 4, I have 300. Ooh, that went down by half. At 8 hours, I have 150 milligrams. At 12 hours, I have 75 milligrams. At 16 hours, I have 37.5, so that's between 0 and 50. And notice you don't see a linear regression anymore. Now it's called exponential decay. So it's going to get closer and closer to 0. Now notice I didn't mention it, but I did it. I labeled hours and I labeled milligrams. Interesting. So let's try. This is what happens when you're just given it one time and after 16 hours you still have some in your system but not a lot. If a doctor gives their patient 600 milligrams of Advil to take every 4 hours for pain, and Advil has a half-life of 4 hours, assuming her patient continues to take Advil every 4 hours, how much Advil will be in her system after 16 hours? We're going to give 5 cycles of this drug representing half-life. So the time still is going to be in hours, and the amount in the system is going to be in milligrams. So right now, no time has passed, but I'm taking 600 milligrams of Advil. In 4 hours, it decayed by half. So now I have 300 milligrams, but then I take another dose. So now I have 900 milligrams in my system. And then every 4 hours, it's going to decay by half, but I'm going to also add another dose. So when I have 900 milligrams, now 8 hours later, I'm going to have 450 milligrams because I cut that in half. But then I took another dose. So now I have 1050 milligrams. After 12 hours, I'm going to cut this in half. 1050 divided by 2 would be 525 milligrams. But then I take another dose. So now I have 1125 milligrams. And then 16 hours later, if I cut that in half, then I have 1125 divided by 2 is 562.5 milligrams in my system after 16 hours. If I take another dose, then I'll have more. What? So that's all half-life is. But as you noticed, I almost have a whole dose in my system after 16 hours because I'm taking it every 4 hours. So why don't you try the next 2 and then come back once you're done and see if you have the same thing I have. So I'm going to continue now. The half-life for the drug is 3 hours. Construct a table to represent a half-life for this drug for the patient who received only 1 dose of 50 milligrams and display it on a graph. So the time's going to be in hours and the amount's going to be in milligrams. And now when I put medicine in, I had nothing in my system, but I'm going to put 50 milligrams. I'm going to take 50 milligrams of medicine. And the half-life is 3 hours, and I don't take it. I just took it one time, 3, 6, 9, 12. And 50 milligrams is going to decay by half the original strength. So then I'll have 25 milligrams, 12.5 milligrams, 6.25 milligrams, and 3.125 milligrams. And if I graph that, I'm going to have my time here and my milligrams here. This time I'm going to go up by tens, 10, 20, 30, 40, 50. And this time on my graph here, I'm going to skip 2 and go up by 3s. 3, 6, 9, 12, 15. So at 0, I'm at 50. So 0, 50, good, because I'm starting on my y-axis. I should always be starting on my y-axis. At 3, I have 25 milligrams in my system. At 6, I have 12.5 milligrams. At 9, I have 6.25. At 12, I have 3.125. And at 15, it's just going to be smaller and smaller. So I'm going to do my graph just like that. Awesome. The next case scenario is the half-life for a drug is 3 hours. Construct a table to represent the half-life for this drug for the next 12 hours for a patient who continuously takes it. So every 3 hours, you're going to take it as scheduled, 0, 3, 6, 9, 12. If we start at 50 milligrams, I'm going to put hours here and milligrams here. Then 3 hours later, there's only 25 milligrams in my system, but then I take another dose. So now I have 75 milligrams in my system. I'm going to, 3 hours later, it's going to be half of what it was 3 hours ago. So now it's going to be 37.5 milligrams, but then I take another 50 milligrams. So now I have 87.5 milligrams. Then 3 hours later, I cut that in half, so now I have 43.75 milligrams plus 50. And I would have 93.75 milligrams in my system. So 12 hours later, when I cut that in half, I'm going to have 46, assuming I don't take any more, 46.875 milligrams in 12 hours. If I took another dose, I would add 50. Awesome. Okay. Let's look at how to read graphs. So for the following graphs, we're going to express the initial dose and half-lives for each drug. The initial amount is always on the y-axis, and amount is always a capacity. So it's going to be, we'll say this is milligrams, and then we'll say this is time in hours. So the amount would be right here, initial, starts at 100 milligrams. And the half-life, the time, half-life is a life, so it's a time, not an amount. To find that, you cut the amount in half. So at 50 milligrams, the time, I'm going to go to 50, go over to the line and come straight down. It's going to be 1 hour. The next one, initial amount, would be 80, and we'll say this is milligrams, and we'll say this is minutes this time. The initial amount is 80 milligrams. The half-life, I would divide by 2 and get 40 milligrams. But my answer, I would go to 40, go straight over till it touches the line, and comes down would be 2 minutes. So this would be my answer, 2 minutes. The time here would be 1 hour. That would be my answer. The initial amount for the last graph here would be where it starts at 10. And it's 10 units. The half-life for this would be at 5. So I'll go to where it says 5. And I'm going to go straight over to where it touches the line and come down. And I'm going to say 15 minutes. And that, my friend, is half-life.